All right, you made it. You made it to the last lesson in the limit of a function. So I'm trying to determine the infant the I'm trying to I'm trying to find the following limits. So there are a few important techniques. One is you just plug in. You plug in the number, you get the answer immediately. Number two is you cannot plug in. You have to simplify first and then you plug in. Number three is you check the left and right. But sometimes knowing the graph is pretty helpful. So let's start with A. So A is we have limit as x approaches to 5 from the right, x plus 1 divided by x minus 5. Can we just plug in? The answer is yes. We can plug in. So when you plug in, the technique is pretty special. I'm sure you have never done that before. So when you plug in, you have a 5 from the right plus 1, and then 5 from the right minus 5. So 5 plus 1 is a 6, and then this is a 5, a little bit more than 5, minus 5. What do you get? Let me give you a picture. So you have a 5. What is a 5 from the right? 5 from the right is you have a number that is slightly bigger than 5. So let's say 5.001. So what happens if you do 5.001 minus 5? You get something that is a little bit greater than 0, right? So we call this a 0 plus. 0 plus is a number that is slightly greater than 0. So this is a 0 plus. Now that gives me something very interesting. 6 divided by a number that is a little bit greater than 0. How do we get this? Let me show you how. So 6 divided by 0 plus. So let me change colors for that. So this is a little technique that you have to use a lot in limits. So we have 6 divided by 0 plus. Imagine this. Let's say you have 6 divided by 0 plus, something a little bit greater than 0. Let me give you a number. So how about this? What is that equal to? Tell me, is the quotient really, really big or really, really small? The answer is if you take 6 divided by such a small number, something a tiny little bit greater than 0, you are going to get a huge quotient past the infinity. What if you have 6 divided by this? Then you get a negative infinity. If you don't trust me, use your calculator, because I can give you one more. If you divide by 6 divided by 0 upon a bunch of 0, right, is the same thing as divided by this. Look at the denominator. Is 1 divided by that number really small? Yeah, 1 divided by that is very small. So you are taking a 6 divided by a very, very small value. So you get a positive infinity. What if you do the math? You take 6 divided by the fraction, which is 6 multiply the reciprocal, then you are taking 6 multiply that gigantic denominator, that is equals to positive infinity. This is something that you have to use in calculus, not in calculus, in limits a lot. Now, one more. Let's say you have 6 and then you divide it by a very large value. What is that equal to? If you take 6 divided by such a large value, pretty much you will get a 0. Alright, so now we return to the problem. We have 6 divided by something a little bit greater than 0. So that is equals to, what? 1? Nope. 0? No. That equals to infinity. That is your answer. So in part B, I'm going to save this space for the secant. All right. So for part B, I'm going to copy the problem for you. So I will just go all the way down. So part B, we have limit as x approaches to 1, 2 minus x divided by x minus 1 square equals to infinity. Oh, no. I'm not supposed to give you the answer right now, right? Okay, we start over. All right, can we do some algebra and then cancellation? You open up the x minus 1, too bad, the top is 2 minus x, nothing can be cancelled. So nothing can be cancelled. Okay, so do algebra is not going to work. Oh, all right, can we plug in? Nope. If you plug in 1, the denominator is 0. So plug in is not going to work. algebra is not going to work, then we check the left and right. So we check limit as x approaches to 1 from the left. This is a 2 minus x divided by x minus 1 square. And then 2 minus 1 minus is just equals to 1, right? But the denominator is interesting. You have to think. You have to do this in your mind. You have a 1, something that is slightly less than 1. So how about this? 0.99999. Something that is slightly less than 1. Alright? And then you take this number, you minus 1. What do you get? You get something that is slightly less than 0. So that means you have a 0 minus square. Of course, this minus 1 is negative, right? Don't worry, you have a square. So once you square that, you have something a little bit greater than 0. This is a technique you have to study in this lesson. I know it's not easy. The first time, if this is your first time doing this, it's not easy. But this is something that you have to learn. There is no way to avoid this. 2 minus 1 is just 1. And then 1 divided by that, 1, just think about this, 1 divided by this. What do you get? You get positive infinity. Alright, let's do a 1 plus. X approaches to 1 from the right. 2 minus x divided by x minus 1 square. Trust me, see, this is more than just a plug-in, right? You have 2 minus 1 plus, and then something a little bit greater than 1, minus 1, like 1.001 minus 1. You have something a little bit greater than 0, right? You square that, that is still a positive. So 2 minus 1 is 1, this is infinity. So they are both equal. Then what about the limit? So therefore, the limit as x approaches to 1 of whatever that function is just equals to infinity. Because the left side and the right side, they are equal. And one other thing, what is the graph look like? The 1, you cannot remove the x minus 1. So since the x minus 1 cannot be removed, the x equals to 1 is actually, this x equals to 1, I should not use a solid line, I should use a dashed line. The x equals to 1 is a vertical asymptote. As x approaches to 1 from left and right, the function, they all go to positive infinity. So that would be your part B. And then in part C, you have limit as x approaches to 3 from the right. You have limit ln x squared minus 9. Okay, there is nothing you can simplify. Why don't you just plug in? So you plug in, you have ln 3 plus square, right? So 3 plus a little bit more than 3 square minus 9. And then this is what you have to think. 3.001. You square that. That is definitely greater than 9, right? Because 3 square is 9. You add a little bit to 3, square that. That is definitely greater than 9. So if you take a 3 plus square minus 9, that is definitely greater than 0. Because this 3 plus square is just equals to a 9 plus. Something is close to 9 but a little bit more than that. So you have an ln 9 plus minus 9. A little bit more than 9 minus 9, you have 0 plus. I know, it's not easy. This is what you have to learn. It's something new. It's calculus level. What about 0 plus? You tell me, what is the graph of ln? Just ln x. The graph of ln x, you have a vertical asymptote, right? At x equals to 0. You have x-intercept at 1. And then you have this. X 0 plus. 0 plus is a little bit more than 0. So x is a little bit more than 0. This goes all the way to negative infinity. So this is negative infinity. See, this is more than a plug-in. Fun, right? Next. part D, what do we have for part D? For part D, we have a secant. So I gave you a graph of secant. You study the graph of secant in your trigonometry. So what do we have right here? So in part D, we have limit as x approaches to pi over 2 from the right, 1 over x times secant x. So if you plug in the pi over 2, the 1 over pi over 2 is fine. So we don't really care about the 1 over x at all. But what about the secant? The graph of secant is right here. And then the pi over 2 is a vertical asymptote. As x approaches to pi over 2 from the right, what's here? That is what? That is like a negative infinity, right? So you have something like 1 divided by pi over 2 times secant of pi over 2 from the right. So this is a 2 divided by pi times a negative infinity, which makes the whole thing negative infinity, right? Something that is very large, like 2 over pi times this. So the answer is just negative infinity. So that is your part D. And then let's move on to part E. So we have to go back down. Part E, change another color. So let's use blue. So part E, we have a limit as x approaches to 2 from the right. And then we have a quadratic expression, minus 2x minus 8, and then x squared minus 5x plus 6. If you plug in 2, you will get a 0 in the denominator. I did the math for you. You plug in a 2, you get a 0 in the denominator. So this one, you are not checking the left and right. You cannot plug in, then you have to think about algebra. When you see quadratic, the square, it must be related to a factor. So you factor the top and bottom. X approaches to 2 from the right. The top is x plus 2 times x minus 4. The bottom is x minus 2 times x minus 3. Do you see the enemy? The enemy is right here. When x is approaches to 2, we have a trouble. But after you factor, nothing can be cancelled. Okay, since nothing can be cancelled, then we try to plug in the plus then. Okay, do we get any trouble from the top? Plug in a 2, plug in a 2. No, I don't see it. So we will just do a 2 plus 2, and then a 2 plus 4. The plus doesn't affect anything. All right, same thing for the minus 3, 2 minus 3. But the 2 plus affects that x. So 2 plus minus 2. So the top, we have a negative 8, right? The bottom, we have, this is a negative 1. And then what is a 2 plus minus 2? Something a little bit more than 2, like 2.001 minus 2. You get something a little bit greater than 0. So this is a 0 plus. And then you have a 8 divided by 0 plus, right? So 8 divided by a 0 plus is 8 divided by this. Just put this in your calculator if you don't want to think about the math at all. This is positive infinity. So this is equals to positive infinity. My brain is not a graphing calculator, but I can give you a quick sketch of the graph. So we have an xy axis. We have x equals to 2. That is a vertical asymptote. As x approaches to 2 from the right, the function goes to positive infinity. Okay. All right, moving on to the last one. The last one is f. We have limit as x approaches to 2 pi. And then we have x times cosecant. All right, cosecant. I don't want to work with a cosecant. Most people don't remember the graph of cosecant, right? Okay, let's rewrite the cosecant. So we have limit as x approaches to 2 pi. We have x times 1 divided by sine of x. So we have a limit as x approaches to 2 pi. We have x divided by sine of x, right? So the 2 pi you can plug in on top. What happens if you plug in a 2 pi? What is sine of 2 pi? Remember this, sine of 2 pi is equals to 0. So in case you don't remember, let me remind you. So this is the graph of sine. This is one full period. Start at 0, end at 2 pi. This is a pi, right? But we have, I think I missed something from the problem. Di? Yep. This is a minus. This is a minus. Minus means x approaches to 2 pi from the left, which is right here. Approaches to 2 pi from the left. Alright, so for sine of 2 pi, so we have a 2 pi divided by sine of 2 pi from the left. As x approaches to 2 pi from the left, y approaches to what? As x approaches to 2 pi from the left, y approaches to 0, but a little bit less than 0. Right? A little bit less than 0. So we end up with 2 pi divided by a 0 minus. 0 minus. What is a 0 minus? 0 minus is like you have a 2 pi divided by this. 0 minus something a little bit less than 0. So the answer is negative. This is important. You don't want to miss the negative. So this is like a 0 minus. If you are stuck on the plus and minus, draw a number line, all right? Just draw a number line. You have 0 in the middle, positive on the right, negative on the left. So this is a 1, this is a negative 1. 0 minus is right here. 0 plus is right here. You have 2 pi divided by that, then you get a negative infinity. So that is how you take care of this limit. So that will be all in this lesson. I will see you all in the next one.